Welcome to Thursday. Here's our plan for today. Gonna get into Chapter 9, Data Design. Talk about basically the emergence of databases from file-based storage to your fancy schmancy multiple relationship databases, and then build upon our GUI. For this chapter, entity relationship diagram. We're going to be building upon our GUI project in Access, actually adding a database behind that. And if you remember your database concepts from the database class, it's more of a refresher, but we're kind of going to not assume that you remember everything, kind of review some of that by building some tables. But even more exciting here, because we're kind of coming to the end and getting pretty piled up with work, if you look here down in section 9, look at your homework. You only see two things to do. There's the e-quiz to review the material, and jumping right to the entity relationship diagram. No part 1 and part 2 and the end of chapter projects, to give you just a little less load here. Plus, we're kind of getting through here a little quicker, more of a refresh on the databases. So let me bring up the book here. Let's see, I thought I had the book going in one of these pages. Let's see. I guess not. Let me bring it up. I do have my hard copy too. I'll bring up. Take a look at Chapter 9. Chapter 9 in System Analysis, 8th edition, as I get signed in here. And look at those first few pages. They talk about how databases, well, they weren't even really databases, how they stored data back in the dark ages of the 1990s. Now, they were smart people back then, so it wasn't like they were doing horrible work. They just used the tools that they had, which was storing data. Where would you store data in a normal computer? Where's a normal place to store data? Yeah, folders and files. And so no one had written, and I will bet you they came up with this idea as soon as they started working with data of, could we be a little bit more organized with it? And so as they're working with data and having multiple files and folders, they got pretty good at opening files, closing files, reading data from files, called parsing data out of files, CSV files. As far as I know, they never got into XML, but that's why, and because it's still a very useful thing to be able to do, read and write files very quickly. In any programming project, I try to include file access, opening and closing files from any programming language. So if you're doing Visual Basic, one of the chapters we cover is opening files, seeing whether they exist, so you don't try to open a file that's not there. All that kind of stuff. Opening image files, placing them in a GUI. They would do that with databases. And why is my... There we go. Go down to chapter 9. They would do that with the data for databases. They would load their data from files. There we go. We're going to be getting into data structures, but they start out with, well, the history of it was with file processing. So, assuming you're using files to hold your data, they would organize their file data into multiple types. They would keep track of customers in one file, and that would be static data, like names and addresses of my customers. And as we got new customers, we would add to that file of that list. Other static files, well, you tell me, what kind of other files would be more static throughout the system that were handling transactions in a credit card company? What kind of static information would you keep about a system running credit cards?
Account numbers.
Yeah, account numbers. That would probably go here with their customers. The configuration. Where are the files kept? That would be probably in a separate configuration file. And if you're a Unix person, you'll know that's somewhere up in the etc folder. Anytime you install some package, typically there's an etc config file, which keeps track of pretty much static settings from the start. Once you decide where you're keeping your files, you never change that. So static information about the system. And now static information, well, generally static information, because customers will change their addresses. Their balance due better change. They better pay their bills. So this is a customer file, but it is changing. It's not changing as much as this transaction file. And in a credit card company, why do I need to keep track of transactions? Why can't I just update balance due? Why do I even need a transaction file? I can just figure out their new balance, update their balance. Why do I need a transaction file?
Just in case the balance doesn't add up.
Right, yeah. In case there's a question, the customer needs to see last month's transactions because, you know, I didn't pay for that. Someone stole my card. You need to keep the historical data of what exactly has happened. So you have to keep constant records of, okay, what occurred. And this is the scary thing about any system that's handling money. You have to have super stable software if you're handling money. That's why it's scary when you're designing a website and someone says, oh, I want to be able to take contributions online. And you think, oh, that's easy to do. I'll just make a database and they can make contributions. Soon as you're taking credit card information, you better have secure systems. Suddenly it's a whole nother step in the security you need to worry about. And if someone's making contributions, maybe they're not so fussy if the balance doesn't quite match what they thought they gave. But if they're a big donor and you miss a zero in the donation, you're in big trouble because now they're tax reporting. You send them a tax report of the transactions. Another reason to keep this is because you have to have end of year summary reports. If those things don't add up, you're in big trouble. And that's kind of what happened with some systems that were done here. Remember I mentioned someone had tried to build a cafeteria card swipe system. It was working pretty well, but then a month or two went by and people were saying, wait a minute, what you're telling me I owe isn't the same as what I think I owe. So can you give me a report of my swipes? Well, first thing was, well, we didn't have that built into our system. Call up the person, we need a report for any user when they request, we need to have a listing of their transactions. Well, after finally getting an answer back, the person tried to put together a report. It was based on access, so it wasn't a huge deal of making a query. But then you have to make sure it adds up, and things weren't quite adding up right. They were realizing when they would swipe by accident, say, oh, wait a minute, I didn't mean to swipe twice, and they would try to remove that transaction, it wasn't quite being removed properly, and so the charge was sticking even though they took the transaction away. And it even gets to be more of a trouble when we get into the multiple relationship tables, where not only do you remove the transaction, but oh yeah, you kept in another table of the amounts. Things got really crazy and he wasn't quite cleaning up the transaction. What he should have done, and I actually didn't see the details, what you have to do, even if you reverse a charge on a credit card, you don't go back and erase a transaction, because you need to show, yes, they charge, but then they reverse a transaction. You don't just go into a database and just say, okay, let's pretend that never happened. That's just asking for trouble. You have to add another transaction to show, yes, there was an incorrect charge, here's where we reversed it, and that stays forever in the database. And just imagine charging, or as you grow, transactions get larger and larger. So processing the files. Now, here's some problems with this. And it doesn't have to be that way, even with file processing. But this was one of our first major problems with a file processing, is data redundancy. That's a big no-no with databases. You'd think it'd be a good thing, like, yeah, we have a backup. But actually for databases, you don't want to have the same data stored in two different places, because inevitably you're going to be changing it in one place, forgetting about the other place. They're not synchronized. That's a huge challenge with databases. Now, when you're doing backup, that's when you think about, yes, data redundancy is a good thing. You have a backup of your database, but your active database, you don't only want to keep your data in one place. And here's the problem with the file processing. Typically back then with file processing, you didn't keep all your files in one place. Each department had their own system and data files. And so if you duplicated a system, or you were keeping track of the same customers, say they're maybe healthcare, or maybe, well, I'm not sure in this particular case if a different department would keep it somewhere, but what they mentioned is different departments would keep similar data, more like the employee data, in different systems, in different file systems. And then you'd have redundancy. When you're updating or firing someone or changing a name or office or home address, they would have to change it in multiple places through departments. Now, saving the data in one common server was one alleviation of that problem if you're using a file-based system. Data integrity is another problem they blame on file-based, because if I have multiple files and I'm changing the structure or changing the data, they may not catch all my files that are changing or that need to be changed. Here is probably the bigger thing, is it made it harder to change the design, because the structure, remember when I have files, how I write data to the file, since it's file-based, would be probably line by line, more, and I would guess probably like a CSV formatted Excel file. You have 10 columns. The 10th column is their first phone number. The 11th column is their second phone number. Very much based on the structure of that file. And that's something, again, if you learn to process files, one of the basic things to do is, maybe process a CSV character separated file and learn what it takes to parse through that. But now just imagine they want to add another column into my structure of data. Really, the only thing you can do is add to the end of every row, so you don't break the programs that are reading column 11 is their phone number. You can't add a new column in the middle. If you planned it right, you can add a new column at the end of every row. But then you have to go back and check your code that reads the files and make sure that the code isn't based on only 11 columns to be read. But if someone's written the code right, they'll say, let's read a whole row of data and read however many columns of data are there. Currently, I only know what's in the first 11 columns. If they wrote the code right, it wouldn't be as hard to manage the data, but it does make it somewhat rigid. I can't rearrange the data at all. So it also becomes slow and inefficient, because just basic file reading, if you just do straight reading text files, parsing through them, that's a fairly slow process compared to fast algorithms that smart programmers figured out for reading from files that are serving a database system. In the long run, and this book doesn't mention it, your actual database is still file-based. Let's just take a look at that here. I like to kind of refresh how that works. Where do I get? Here we got to go to a system here that has a database on it. Let me connect to a system that's pretty safe. I think it'll let me in. I am in the eLearn2 system right now, and the eLearn2 system is based on MySQL. But guess what? If I go over to the right place, see if I can remember right. Let's see, I go to the directory MySQL on the system running our database. They are actually creating files to handle my databases. And our latest Moodle database is that guy right there. Let's see what's down in that folder. Oh, I guess I got to be super user to see that. I can remember that password now. And look at that. It's got a file for every table of my database. So databases, even MySQL here, modern 2.7 of Moodle, which isn't too old, still, and MySQL is up to date. Everything in MySQL is file-based, but it's all hidden behind procedures MySQL code to actually access the data. Just for fun, let's look what's inside of one of these files. See if it's even readable. Let's look at, well, let's list their sizes. Don't want to list a huge one. Let's see here. Looks like the FRM files they may be tables, or they may be simply the structure of the tables, because they're not looking like they're getting too big. Let's look at something. How about Moodle? Look at all the tables in just this is the learning management system that our Tim's project is kind of based, well, it's kind of similar to, but just handling the coursework, not so much handling accounts. Let's look at the course.frm file. Moodle course FRM. Oh, MDL. Look at that, it's not even human readable. So I'm seeing some human readable data in there. Interesting. So the data in those files is where the data is being stored from my database, but in a special, probably a highly efficient, stored, maybe even encrypted as far as I know, if there's any kind of security happening. You'd want to be sure that would happen if I actually am keeping track of users, which I think there's Moodle users way down towards the bottom, which probably keeps track of your password. So if somebody broke into my system, look at that, there's my user info, user table. So although they're saying, modern databases aren't file-based, there really are files in the back end, but to you it looks like it's a structured, highly structured, efficient data structure. But because our systems are based with files and systems, somewhere in there it is kept in a file. They spend a little time reviewing actually how files were structured in the file-based system, just because you use similar concepts when you use database system. So things to remember there is that you have the master file, like the config files. If you have a specific list of products, I might even consider that more changeable than I would think like a configuration. Here's where I'm keeping my files. Here's the location of the IP addresses of the other servers that work with this system. Their master file has like products. Well, I would expect products to probably be updated regularly, but not as often as table files. So those would probably be tax tables. If I'm doing mathematical graphics and I want fast graphics, I don't even want to calculate sine and cosine when I'm figuring out the angle of a bullet that's going to be shot across my game server. And I would probably keep a file of mathematical calculations. If you're doing a graphic game server, you would have a table of your actual world that you've generated for the players to interact with. That would not be something that you would generate if you want fast graphics. You want to have that, oh, I just go read what my world is, not calculate and build the mountains every time I enter a room. Same with something having to do with finances. I would keep track of current tax tables and maybe update them once a year as the government wants more and more of them. Transactions, we talked about that, keeping track of day-to-day operations. Temporary files, as they're working with data and just want to manipulate it. A temporary file in a Access might be a report that I need just for today. I can quickly generate a report and then delete it because I can generate it on the fly next time. They would keep backup and recovery. They call them security files. I would probably just call them backup. One thing you don't want to do is delete your transaction files until you make sure that they are in a backup, so you have some sort of audit trail capability. With our TIM system, what's our historical data we'll need to keep in our TIM system? Think of something that in 10 years someone might still need to see if they've been a student or teacher. Yeah. We regularly here at Emmaus get people asking for their transcripts from the 1970s. And that was on an old system that we still keep around because it's a very efficient system. And would you believe it, a system that we put in 1980 is still running without significant modifications. Let me show you a page of that system. I'm proud just to be able to keep it running, although it had nothing to do with the actual getting the program to work. It's low security. I can telnet into it, and we all know telnet is not secure, right? What is better than telnet? Or what is, you never use telnet if you have this available. What would I rather use? Yeah, never use telnet. If someone sells you a system and says, "Oh, run telnet to connect to our system," you know you're in trouble. Here is our database system based on a language called MUMPS, or now known as M. Very efficient database system. And I didn't enter the password soon enough because I forgot my password. Let me see if I can get into there again. I remember my password now. There we go. Now I'm in a system. This is based on the M language, and I have no account for a person named Linda, and I can enter. Isn't that a cool user interface? I enter menu numbers one at a time, going down level by level, choosing menu items all the way through. And let's see, there's my brother Philip, there's my wife Lois. Let's take a look at her records. Yep, got the current address. Now F11, I'm not sure what that'll do for me. Look at it, it actually has her current information. because they are still using this in the ECS system. Emmaus used to have all student records in this system, and they still do. Previous to 1995, all the student records are still kept here. So we keep this system alive, and I think they have pulled some of the information out into Empower. I believe they actually, when they first did Empower, one of the big things they did was data transfer out of this system. That was not an easy project. And sometimes when you're doing a database project, the actual data transfer out of the old system takes as long or longer than the design of or the installation and entry of new data. So if you're doing a database system, plan on spending money just doing the data transfer from old systems. Another problem with file-based, the rigidness of the structure makes it more difficult to do an update. And there's our history file for archiving. Okay, so then they basically go over the structure. This is the same kind of information you'll need to keep in a database system. So it's not like we're throwing away all that we learned with file processing. Databases are essentially the same idea as using file processing, cleaning it up a little bit, keeping all the information in one place. That's your first big advantage. So different departments don't have a copy of the system. That can also fail. They share the data, and you've also centralized your backup and management of that database. This is where Microsoft server machines come in. And any server would be the machine that keeps all the information centrally. You'd have the database programs running on the PCs in your various departments. But in the center, you have your central processing. Now, this is a concept that people try to follow just to keep their sanity. But now with the cloud happening, it's kind of breaking up this concept a little bit. And that can lead to wacky problems as people realize, oh, I can keep this data in the cloud. It's sort of centralized, but it's easy to lose track of. And remember, you become much more dependent on network, and security becomes an issue. And databases are also becoming less structured with just there's so many types of data out there. The popular thing now is becoming the non-relational databases or unstructured data out there in the cloud. You need to know the advantages of your database system, which are I can scale it up as I add more users or change my needs. That's going to be a problem with file-based. Just because it's more structured, it makes it, because smart people have structured it and they've realized the need for change, they've designed in the capability to change more easily. With a file-based system, if you have a smart programmer, you could still do the same thing. If they've carefully designed their files for future changes, it just is harder to manage when you don't have a common type of database. That's probably one of the things. I don't remember if they've mentioned that. I guess the economy of scale is part of that. When everyone is using the same database, it's easier to go from one company to another with database expertise. So that's why SQL, knowing SQL, how to manage it, Hannah, at the server end, how to program it as well. You've learned it for SQL. Many people are using SQL, so from the administration or programmer point of view, you have many more customers, potential customers or employers if you know SQL. Same thing with MySQL, which isn't radically different from SQL. So it's economy of scale for the user of the database, economy of scale for the administrator. You've got a common standards to use. So that's where that comes in. Stronger standards for you as a user or designer of the database, and consistent standards across applications. And that's why databases have hit it up pretty big. There still is a lot of competition just because, I kind of look at the same as why we have 1,000 different programming languages. You think it could get by with 5, but There are lots of different database designs customized for and optimized for specific markets. So they talk about the efficiency. There's the mention of the programmers that they're not learning custom structures. Data independence, I can alter my structure without breaking it. And if you remember back to our database time, we're going to go into our Access database. I can add a field in a database, and I don't break any SQL code, because my code isn't saying go find column 11 of the file. It's find me the field named last name. To SQL, it doesn't matter if you've inserted a middle name between first and last name. The code is just as fast. You don't have to redesign the previous software. But you will have to, if you want to work with old tables, you'll break your software if I'm now looking for middle name in my other code. It'll say, uh-oh, field not found. So it doesn't guarantee that you can't break it if you're not carefully programming it. There's still a problem though with, and we'll see that with Access. Just like you can turn in your Access database, upload it to me, and I have a copy of your Access database. Imagine a company using a database in one department. If they didn't follow the structure, they could easily make small department version of that database. So they still have to be careful that if they want to keep the centralized information, they have to make sure that they are doing that. And you've got to spend some time making sure that your company-wide resource that you want to avoid, what problem are we avoiding if we're keeping it in one place? Yeah, we're avoiding redundancy, which is important, but that demands some structure in our company that we pay for a good network to get to that central data store. If I don't pay for that network, there's going to be a department, the warehouse, typically far away from administration, just because there's a lot of big trucks that have to get around the warehouse. I better have a good network link to the warehouse. And if I'm a Walmart, I better have satellite links to all my locations, as I depend more and more on a centralized design. Smart database administrators and smart programming systems, they will actually plan for that, where you actually have a local database just in case I do lose contact with the central administration of my company. I can still go on and keep going with transactions to a limited extent, but mostly full speed. And then when the connection to my main corporate comes up again, I automatically synchronize my data with corporate. Very common for small companies. I was working at it was like a loan office, and improving their network, they had a regular synchronized software, and their network was just bogging down. We added some new equipment. Their system was an automatic synchronized with corporate at the end of the day. Now I'm sure their processing, they had to be at least verifying customer accounts through corporate, but the local system had that very plan in mind. Just because their network might go down, they don't want to say, oh, sorry, we can't take any money today, customers. The computer's down. You want to still be able to take the money from the customers and synchronize later. It gives some more flexibility, but flexibility to the user, but more complexity to the programmer. So in our database, we've got our manipulation language. What is that with Microsoft? Yeah, that's SQL. MySQL is the open source. SQL and MySQL, not terribly different. And database management systems, the one thing to remember, a common term that comes up with databases, I'm not even sure if the book brings it up. Do you remember the word CRUD for database systems? CRUD is an acronym for Create, Read, Update, and Delete, referring to records or data design in a database. So they talk about some of the basic things. I'm going to skim over that. Be familiar with the various databases out there. We've got mentioned here Oracle, IBM's DB2. I'm not sure how widespread that is. I know my brother-in-law at IBM, I think they use DB2. They have this thing called TAD4D, but I'm not sure what it's all about. I think it's more than a database. An acronym for something. They have actually acronyms based on acronyms at IBM. They're so into acronyms. But the languages, well, here's how I figure out what languages I should be familiar with. If I'm configuring a system, I'll go back into, I think I have my, let's see if I have that up here. Where's my putty? Let me putty back into my Moodle system. When I go to where I keep the software, here's one way I'll typically learn about what are the important databases. When I go to install some software, where is it? And I look at the configuration or the setup file, and as I go through that, I'll see, oh, what databases do they offer for configuring this system? Here's where I see, wait a minute, PGSQL, Postgres, MariaDB. What in the world is that? That's actually a new thing I'm seeing in the latest Linux systems. It's replacing MySQL. It's actually a name. I'm not sure exactly what the case is, but they call it MariaDB now instead of MySQL. MySQLi is some variation of MySQL. MS SQL, I think that's Microsoft SQL. SQL Server, I think that's also Microsoft. OCI, I believe that's Oracle. So when I come to packages that I've downloaded that are database driven, when I see the list, this is one thing that tells me, I should probably know something about those 6 kinds of databases, because in this fairly well-known package, they've made it compatible with those 6. As you come across other areas of interest where you're handling data and you find software, you will see what databases they connect with. That's one good clue that those are databases to maybe learn a little bit more about. For me, I've learned that I have to use MariaDB when I'm configuring. That's the same as MySQL that's been up till this last year. Suddenly Linux is now, or at least it's Ubuntu, and no, CentOS Linux is using MariaDB now as their standard, replacing MySQL. So knowing the various databases is an important thing to just keep up with. And fortunately, the database languages aren't radically different. Well, they've got a lot of other concepts here, but let's just get hands-on with Access, and we'll see we're dealing with our schema as we design our table. We have other schemas based on relationship with different users or systems. We're not going to have to get into sub-schemas. As we design, basically the schema is when you're in design view with Access, you're controlling what different fields contain. That's your schema. That's the definition of your database. More in the schema when you're in Access is when you're looking at relationships between tables. That's manipulating the database schema. Another name I think is similar, or it may be exactly the same, is what they call metadata. What information is in there And then it's what data is actually stored in the records. So let's just get into access, and as you use these, we'll try to relate it to the more general terminology with databases. And I've given you in the assignment what you actually need to do. It's over, where is that? Not there, not their practice quiz. Here, not your entity relationship diagram. Oh, we're gonna build the tables and then create the entity relationship diagram. So our homework is eventually creating the relationships and showing it graphically. But let's start with actually building the tables to refresh our skills in Access, and then we'll come back and build these entity relationships. And I think we can even use the Access relationship. That might be good enough for my entity relationship diagram. Okay, so let's build the tables first, and then we'll come back and edit our relationships. So here are our tables, and in a past time we've had different people doing the different courses. So we'll divvy up 3 tables here. How about Hannah? We'll talk about these 2. The course table, we're going to list the course names. And Micah, let's see, I guess in this we just did courses, roles, schedule, grades, assignments. We'll see, at least let's build, maybe we'll build them one by one. We'll build the courses table together, and then we'll see if we can divvy up the work into multiple tables, because that's where you have to worry about the relationships. So let's bring up Access, and I don't have it running yet, so I will start up Access. And I'm going to open up the same database that I built my GUI with, just to keep all my work together. And eventually, if we have time, we can actually connect our forms to the actual data in our database. Here we go. I've got my Tim's GUI. My Tim's GUI isn't quite as complete as yours. I've got 2 forms, and my student forms, there's my student page. There's my main page. All I had was my student link, and it takes me to my student page. But yours are much more complete. But we've built forms not even worrying about our database structure. And this is one approach you can make to designing your database, is just design your forms first to know what it's supposed to look like to a user, and then connect databases that then you can easily, well, relatively easily connect actual real data from your tables. So create table, and I'm not even going to use the table design. I'm just going to go create the table. There's my table. Actually, I do like the designer better. Let's go to the triangle designer. Give it a name. Let's call this one courses. The reason I like the designer view a little better, can I zoom in on this? Let me try zooming in on that. I think I have to use my projector to do that. One reason I like the designer here is because it looks a lot like what you'll see if you're doing it in MySQL. You can generate this in a text file with MySQL and feed it to the MySQL, read the SQL, and it will generate tables. Not a lot different in how it's listed. Have I showed you, have we gone to PHP MyAdmin? I remember we were doing that in your database course. That was another thing similar to Access, but we'll just stick with Access for now and not worry about PHP MyAdmin, because we don't want to have to worry about dealing with a server. We just want one compact database file. So now you can help me out. What do we want to put here with our courses table? One thing I'm going to do is I like to have, instead of just this standard ID, I like to call that ID course. So each course has an ID. Some people like to use course underscore ID, ID underscore course. You can choose if you want the Hungarian approach, reverse, put the noun and then the description. what information do we need in our schema, our design of our course table?
Just gonna list your classes, aren't we? So SQL, Visual Basic.
Well, that's going to be in our records, right? The records we will add to this table will be information going row by row. So at this point, we want to design, when I'm entering information about a course, what information do I need? Well, that will be a query. How many students are enrolled will not be in my record of courses. I will think of this as being my course list that a student sees to know what he can sign up for. So eventually, I'm going to have to keep track of transactions that they have registered for a course. But I just want this table to contain only the course information, the more static information. Yep, that could be a start date. If we have an ID, and we can put this in any order and rearrange it. So we'll put start date. Now, I'm going to follow my similar structure. I'm going to go date start. A lot of database designers like to make it all caps. That just gets real hard on my eyes, so I don't go the all caps like you'll see with some designers. And since it's a data type, since it's related to a date, what data type do you think I want to use? Yeah, let's try date time. All right, what else do I need to enter information about my courses? This is like a master file. I'm not going to see my students' names here. I'm just going to see the names of courses here. Yeah, date end, that's good.
And you have a course title, right?
Yes, definitely. I have a title. And that would be probably short text is good enough for that.
Would you do instructors here, or is that also going to be like?
I'm thinking that.
Because that's a little more static-ish.
Well, yeah, we'll make it static for now. As we get into fancier system, you might have that in a whole nother table where we keep track of what instructor was the teacher for that course throughout history. For now, we'll just say ID of instructor. Implying, what is this implying? That this is going to be a relation to my either instructor table or a user table where this happens to be the username. What should I use for its data type here? This is very important because I'm planning out, as I'm doing this, I'm sort of planning out my relationships to the other tables.
It's going to be auto number.
Not auto number. Yeah, you're getting warm. It will be eventually in a form. I'm going to want to assign an instructor based on who are instructors. But because, and basically this is related to how I'm expecting to design that instructor or user table, it's going to be auto number in that table. So I better make it a number here. Auto number means I'm assigning it every time I create a record in this table. Number means when I'm linking it to another table, like who's my instructor, and I'm going to put in my comments here, ID from or related to, or how about ID of instructor in the instructors table, or from the instructors table. That is the relationship I'm designing in right now, that I'm only referring to the instructor by ID, but that will be a key in the instructor table. And already I'm thinking, oh, okay, instead of having all users in a role, am I going to have a, or will this simply be the ID in a user table, and the user table determines who's qualified to be teachers? Because instructors or users or students all have to log in. Once they log in, I know based on their status, are they the teacher or the student? And that's something that we would be hashing out in the design. Our instructors are allowed to be a student in another course and treat it just like a student. And with the Moodle system as my kind of model, I'm thinking, yeah, that makes sense. I'll do it that way. What else would we need to know? Keep track of courses. Title, instructor. How about description? Because this can be a little longer, and this actually may be the web page for my course. Instead of short text, I'm going to let this be long text. It used to be a memo type in older versions of Access. I could even make it a hyperlink. How about that? We'll make it long text. It can be a very long description, even perhaps HTML. And it may even be read by my website PHP code to pull the description and actually display it in my pages, read it from this database. Let's go ahead and put in case our class does have a specific URL, we will enter that here. And I like that because to use that, I see Access offers a specific hyperlink data type. Yeah, good idea. So I would have
Like classroom ID or something, I don't know.
yeah, because that's going to need a lot of extra information. Let's go ahead and go ID. How about just location? I like the general terms, and again, because that's a link to another table, I'm going to give it the number data type, because links always link to the key field in those tables, which I'm going to go with auto number. You don't have to use auto numbers. Remember, that's a convenience. Access automatically makes auto number, letting Access or whatever database system assign that when you create records. There's a lot of database systems I've worked with. Don't make that auto number. You have to assign it at the point where you're creating records in that table. But it still would be something that has to be unique to a record, or it's a worthless key field. So ID of location. Now this is implying that we now need to go and create a location table. Any other things, we can always come back, because this is a database, we can always come back and update our schema without breaking code, at least not breaking old code. How would we break old code that depended on using title? Yeah, I could change this field name, and now I have to change my SQL that referred to title before if I decide I didn't like that name. Or if I delete this field, if I modify the schema by deleting things, I've broken old code that was reusing the title field. And so it's not completely unbreakable, because I can remove things. So what you'll typically do if you're modifying the schema, you will never ever change existing fields that are in use by your code. You will always add fields, and you're not going to break anything, which is the problem when you realize you've got a lot of unnecessary fields, but you're never deleting them because you think old code might be using it. You eventually have to say, okay, let's stop and redesign. We've got a lot of fields that are being just wasted space in our database, confusing programmers. Let's just say from now on, we're deleting some fields, and now we're no longer backward compatible with anything previous to version 2, throwing away fields that were used in version 1. Something that is a very scary thing for programmers, but the database makes it a little more manageable. But it doesn't guarantee good code. You can always mess it up. It just makes it a little easier to modify your schema. So there's our courses. Now, one thing to do when you're doing a database, let's just go and enter information in this table. And as you enter it, we can adjust our column widths, and I can adjust my locations of things. You know, how about the description goes right next to title. Let's move that field. Can I grab that and move it? It'll let me do that. I can always go back to design. Let's see if it changed the location when I went to design view. It didn't move it then, but I can move it if I want, even here, to just group things and more logically. I can put description, just grab it in the gray and move it below title. back to data sheet view. I still have this title and description. I can now enter date start. Because Access gives me a convenient date start, I can use a calendar that's built in if I make it a date type. Let's enter a date for date end. So entering a couple pieces of fictitious data, you realize, wait a minute, I should have this information. So quickly just using it, let's just make up a course name, CS. Uh-oh. Do I want to separate the actual course number from its title? Like the cs412, that could almost be the course ID that I would enter manually. But let's go with this cs412 because I like to keep a separate course for each semester. Let's call it Spring 16 for next year. And descriptions, system analysis and design. I may have wanted that to go in my title. You might call this maybe the description could be long title, where this is the short title. And Moodle does that. Moodle has a short title field and a long title field. I can't enter anything for my ID of instructor yet because I don't have my instructor table. I can make up a URL, www.emmaus.edu /cs412. I'm a little sad that our Moodle system that we have, if you've noticed, I can't get a good URL for courses. When I go to this course, look at my URL. Kind of an ugly URL. It'd be nice to just say elearn.emmaus.edu /cs412. But because we've built this into we're using Moodle, it uses database keys and things as my URL. There are some pieces of software that will actually map these strange URLs to actual more human readable, like cs412. And maybe that's something we'll consider with our distance ed initiative, is making the URLs look a little nicer. Currently, they're the default Moodle URLs, pretty ugly. You can't put that on a brochure. Come to our course. No one's gonna type all that. So there's ways to make your URLs friendlier looking. So entering one piece of data, just using it, you'll realize, oh, maybe I need this field, or maybe I need that short description. But then I can close that table, and I'm done with it. Saving any changes because I modified my column width it's asking me to save. I'm going to close these forms. And now let's work through and maybe get you a start on the other tables we need. Let's look at our assignment description. Here we've discussed tables that we probably would want. In our previous design, we have a roles table. We discussed having a users table, but then we can assign roles to a user. And I got this idea from just seeing how Moodle has their things designed. So I have a users table, but then I have another table called roles. That is what roles I can assign to different users. And it's a fairly small table, but that determines their privilege throughout the system. If they are an admin, anytime I'm doing something that needs admin privileges, all I do is check their user ID and what their role is assigned to them in their users table, and let them do anything they need to do if they're an admin. So which table would you like to go through? We've given you ideas based on previous design, but that doesn't mean you have to specifically follow their ideas. But they're probably not bad. So we just did the courses table, getting that idea from previous. Okay. Let's go to access here. So grades table. Now we're kind of designing this on the fly. Imagine doing a real system. You'd be sitting in a meeting room, and on the table, Post-its flying on the all over our whiteboard, thinking about, or maybe you just assign it to one person. Give us a preliminary idea of your design for a grades table. Then sit down in a meeting and have that person display it, and then start looking at the entity relationship diagrams or their list. Let's just go ahead and do that on the fly here. We'll create. I'm going to go right to table design. Oh, look at that. With table design, it doesn't put the ID field in there for me. So ID grades. This is more like a transaction table where I'm keeping track of specific grades assigned. So it's going to be a lot of links to other tables. So every grade entry will have a auto number. I'm going to use auto number for my first, and I'm going to make that the key, the primary key, by clicking the primary key right there. And just for sanity's sake, I always make it my first field. Not going to talk about combination fields and second and third order forms today. We talk about that in our database course. Remember all your second and third order, fourth order, gets kind of confusing. We're not going to worry about that. Let's just put in what makes sense to keep track of grades. Yeah, it's going to be an ID of the course. What course was this grade assigned in? ID course. And I have to make it the same data type as what it is in that table, so I better make it a number. And that's another advantage of keeping consistent naming. When I'm referring to ID, that's a signal to me. That's probably got to be a number because it's a link to another table. So, and it tells me I better have a course table, which I do so right now. And I'll just say link to course table. Now, is that a one-to-many relationship as I think about this relationship? For each grade in this, each grade record, does it refer to one or many tables, courses? What's the relationship between my grade table, course ID, and my courses table, which has course ID for every course? Yeah, I think so. I've taken one course, this course name, and I've received a grade.
So how do you know who the grade is?
Yeah, we better have ID student. So a grade, for every record, a grade is going to have a course assigned that I got that grade in. That's going to be, there's only going to be one record for that one course. So it'll be a one-to-one relationship, one-to-one. Then you have ID student, who's getting this grade. Again, oops, I accidentally typed a quote, can't have that. And again, that's a link to another table. So which student receiving the grade? Now, are we going to make a separate instructors and users and students table, or are we going to make a users table and have roles assigned to different users? That's a design choice at this point. I'll leave that up to you. What would you like to do? Have a separate student and instructor table, or have one users table with separate roles in their user information?
You just do a drop down and figure out what the role is.
Yeah, once you're entering data, yeah.
Probably do the drop down. That sounds pretty easy.
So then this would be a link to a user.
So would it not be ID student anymore, I guess?
Yeah, to be consistent, I might want to change this to ID user, and user is a more generic term but it will be the actual student. So it's going to be a student in the course, but since we're going to now call it a user table rather than student and instructor table. And that's I've come across some databases like that where the name of the table, you can tell that they meant it to be for one thing, but later on they changed the design, but they left the old name because the old code is depending on table names, and the table's actual usage doesn't really match its name. And that just drives you crazy when you're coming in to learn the code. You finally realize, oh, they meant this to be a more generic user table, but they're calling it a student table. So a user, a course, at some point I better have information about what grade they received.
And this would be like the course grade, right? Like
Yeah, yeah.
final, you got A.
Right.
Should we put how many credits it's worth? No.
That would be in the course, so yeah. But when I'm doing a transcript, I will need to pull that into my report. Oh, and maybe in my course, I better go back and maybe put number of credits to go with that course.
Can we just put grade?
Yeah. And we want to make it a number or a text? Letter grade or number grade?
Also the text, can you also put in number or?
We can make it two fields. One called just the value of the text, the actual letter grade. So we'll just call this letter grade, or we could say letter grade and then percentage.
So short text only takes text, it doesn't take numbers.
Well, yeah, you can put in numbers, but then you can't do mathematical operations with it. Down here in field size, we don't care about this in small databases, but if I'm only giving it a one letter, I can make the field size 1. Actually, I better make it 2 because I might have minuses and pluses. And now the number grade to go with the, should I call it the grade to go with the GPS, or just number? What do you want to assign a number, or do we want to leave that to calculation later? If I get an A minus, I assign a number in some code. How about grade value? And we'll make that a, okay, I only have, let's see, number. Let's make that a number, but then the type of number is not integer, but a single precision floating point. Again, that's in my details of my schema. I can control what kind of number it is. And so this will be used to calculate GPA. So we'll call that use for GPA calculation in my comments. So in the comments, it's helpful to give some clue to the next designer coming along. Why in the world and what do we do with this value as they read their table? In my practice, I generally avoid the underscores except for the ID part. You're welcome to use underscores, and I think Access actually lets you use spaces, but most database languages don't like spaces. And later on, I think Access actually adds them to the actual SQL code. But we'll stop there and leave it up to you. Let's decide now. We've got this table. I'm going to save it and give it the name course table.
Grade?
Oh, sorry, grade table. Now your assignments, we have these other tables, and what I'll let you do is you can create a table and then share it to the other person. You can actually you can just share the database file with the other person, and they can just import the table from the other database. So do you want to pick a table to design to share with your fellow student? We see here we're going to need a user table. How about a user and roles table? Who would like to do that? The roles table is not going to be very long. It's kind of described pretty much right here.
Isn't users and roles?
That'll be two separate tables.
I can do that one.
So make a users table, and their role would be a role ID, and then a roles table would basically be these 4 roles. But the cool thing about that is if I decide I want another role to assign, like a teaching assistant, I don't have to change my structure. I simply add another record to my roles table. And then, yeah, user table and a roles table. And one of the fields in the users table will be role ID, or ID role if you want to follow the same ID scheme.
And then, aside from those tables, is there the other homework to do, or is it what else?
Then once we do these tables, what we'll do then is using the relationship diagram and axis, we can essentially draw our relationship diagram. So the goal is once we have our tables in, we're going to do an entity relationship diagram between them. So Hannah, so far we have courses and grades, and now we're going to have users and roles. We're going to somehow need to get a transcript or transactions. Oh, assignments. How about an assignments table? Within a course, they'll be doing assignment. Yeah. And as you do the tables, which happens all the time, you'll realize, wait a minute, I may need to change my design as you think about how this all works. So make the tables and add entries into them. And as you do entries and start using it, and this is where prototyping actually does all the work. You do a prototype, and as you're doing that, other ideas come to mind of how it needs to be designed. We're kind of throwing that all together as, let's design these tables. And the goal is, once you have them, we'll do the entity relationship. Letting Access help us with the most of that, but when we do the relationships in our Access database. And if I come up with some ideas, I'll add another table and I'll share it with you. So as you come up with things, you're welcome to email back and forth your databases to share your tables.